Hello again, my mathematicians. This video is the third video for section 7, which is simplifying algebraic expressions. So always put the title on your note page so that you know what the topic is that you're covering, especially if you need to ask for help. Remember, we do have, I have office hours. The Math Center is open for online tutoring. So it's helpful when you know what you are learning, okay? So definitely make sure that you understand the vocabulary and you put titles on your note pages. So in the previous video, we talked about what the difference is between an expression versus an equation. An expression cannot be solved. It doesn't contain an equal sign. So we're focusing on simplifying here, getting it into the smallest number of terms that you possibly can. For example, if I have 3x minus 2 plus 7, all right, we're going to start off with something like this, just where we're combining the numbers. Negative 2 plus 7 can be done. I can put those together. Negative 2 plus 7 is a positive 5. So this would be 3x plus 5, okay? This whole thing comes down to the idea of combining like terms. First, we need to know what a term is, and then we need to talk about what it means to be like. So let's define a term first. Okay, in general terms, it's the chunk of an expression. Okay, or in other words, it is products of variables and numbers separated by addition. That's what it means to be a term, okay? For example, if I take a look at our simplified expression up here, 3x plus 5, there are now two terms, 3x, that's one chunk of the expression, and positive 5, that's another chunk of the expression, all right? We don't want to identify terms until we are, how many terms rather, until we are totally done. So this would have two terms, okay, by the end. Now let's talk about what it means to be a like term, okay? So like terms. Like terms are terms that contain the same exact variables raised to the same exact exponents. So in other words, the variable piece has to look identical for you to consider combining them, okay, for them to be like. So in an example, kind of like what we had before, except this time I'll do x's. What if we had 2x minus 5x equals, or plus 7? Now the like terms are 2x and negative 5x. And there's absolutely nothing wrong with identifying your like terms. Matter of fact, that's a really good strategy. So I'm going to combine 2x minus 5x. 2 minus 5 is negative 3x. And then don't forget about that plus 7. I can't go any further because this is not like, okay? These look totally different. I can't combine x's and whole numbers. So this is where I would stop, okay? And now I can see that there are two terms when all is said and done. Okay. What if we had 3x squared minus 4x squared minus 2 plus 5x minus x? We're looking for like terms, okay? I have x squareds that are going to go together. Okay, those are like. I have x's that are going to go together. Notice how I'm using a different symbol to identify different sets of like terms. And then I have just a -2 that doesn't have any partners. Now I can start to combine these terms. 3x squared minus 4x squared is -1x squared. 5x take away 1x, because you could always put that imaginary 1 in there, is going to be a +4x. And then don't forget about that -2. So this is what we're talking about when it comes to like terms and simplifying the expression. Before we get into more difficult ones, we need to talk about a really important property called distribution. Okay, and you might have actually heard of distribution in previous math courses, so this is just going to be really quick. The root word of distribution is distribute. And to distribute means to give out. We all know that, okay? Beer distributors, newspaper distributors, okay? What do? They actually give it out. Distribution looks like this. Let's say I have 5 times x minus 2. Don't ever forget that PEMDAS exists. If I looked at this and I tried to use PEMDAS, what's in the parentheses can't be combined. PEMDAS would wind up failing me, okay? I need another way around it. I need a workaround when PEMDAS doesn't work. The workaround to get through parentheses is to bring in that outside value that is touching the parentheses. So this is going to be 5 times x, which is 5x, and 5 times -2, which is -10. Okay, this is our distribution. What if we had -5 times 2x minus 3y plus 8? If I tried to use PEMDAS, I can't combine x's and y's and whole numbers. Okay, there's nothing I could do in here. So I use distribution. Notice how I even draw these arrows. That's another good habit to get into so that you don't lose track of what you're multiplying. This is going to be -10x plus 15y, and then -40. We're just doing each of these operations. And you can do those intermediate steps with the help of a calculator. Okay, that's totally fine. Now, the book, unfortunately, doesn't have a lot of really good practice with simplifying expressions, okay? Because I really want you to get the hang of putting a bunch of things together, multiple sets of parentheses. So let's start trying to build up a little bit. Let's say I have 2x minus 5 times 3x plus 1. Okay, and again, all of these, I haven't been writing the directions, but all of these are asking you to simplify. Okay, I look at my parentheses first because in the back of my head, I should always be thinking about PEMDAS. I can't add 3x plus 1. The only way for me to get rid of these parentheses is to do this distribution. The 2x has nothing to do with that distribution because it's not touching the parentheses. Only the -5 is. So I'm going to copy down the 2x. -5 times 3x is -15x. And -5 times 1 is -5. I'm not done yet because I notice that I have like terms. I can add 2x minus 15x. 2x minus 15x is -13x minus 5. Okay? Let's try one with multiple sets of parentheses. Let's say I have 3 bracket 2 minus parentheses 4 plus 3x. And then close the parentheses and close the bracket. When you have multiple sets of parentheses like this, and that's all the bracket is, by the way, is just another set of parentheses. They're just doing you a favor so that you know which one pairs with which one. I'm going to focus on the innermost parentheses and then blossom out, okay? So PEMDAS is still in the back of my head. I look at 4 plus 3x, but I can't do anything with that. So I look at what's touching it, what's affecting it. There's a minus sign here, and if you feel more comfortable, you can put a 1. So this negative sign is affecting that parentheses. Nothing is happening with this 2 right now, and nothing is happening with this 3 right now. So I'm copying down the 3, I'm copying down the bracket, and I'm copying down the 2, because I haven't touched any of that yet. I'm multiplying -1 times 4, which is -4, and I'm multiplying -1 times 3x, which is -3x. What I successfully got rid of in that first step is the innermost parentheses. Okay, now my eyes should refocus, and I'm now in these parentheses. I do see like terms. So I'm going to do 3 parentheses, 2 minus 4 is -2, and copy down the -3x. I look inside my brackets and I realize I have nothing left to combine. These are not like terms. So the only way for me to get through the brackets is this last distribution with this 3, and that's going to leave me with -6 minus 9x. These types of problems, especially because they will be getting longer and longer, take very much attention to detail. Copy down exactly what you see from the previous step and only focus on one thing at a time. Okay? I'm going to be posting more problems for you to work on because this is going to be an extremely important skill before we get to section 8, which is our algebra and solving for x, or solving for a variable. So you want to get really good with manipulating expressions. So this way you'll be better with your algebra when the time comes. So work on Lumen, work on the worksheets that are going to be posted in Blackboard. And I will see you in the next video.